Good morning everyone. So let me continue with the moment of inertia derivations. So in the last class I have discussed regarding 3 to 4 derivations. So the first one, to find the moment of inertia of a plane area, that is Ixx is equal to integral of y square dA. Similarly Iyy is equal to integral of x square dA. And I moved on with the polar moment of inertia, that is Izz is equal to integral of r square into dA. Next, I discussed regarding the radius of gyration about xx axis. Kxx is given by square root of Ixx by a, and Kyy is equal to square root of Iyy by a. So then I moved on with the other derivations like the perpendicular axis theorem and parallel axis theorem. So what is that perpendicular axis theorem? So it is Izz is equal to Ixx plus Iyy. Similarly, I also derived parallel axis theorem. So what is that parallel axis theorem? If I want to calculate the moment of inertia of any particular area about any other axis other than the centroidal axis, so that is IAB is equal to Ixx plus AH square. Then I also discussed in my previous video regarding the expression, that is to find the moment of inertia of a rectangle using the first principle. So about xx axis it was BD cube by 12, about YY axis it was DB cube by 12. Then I also discussed regarding the circle. I discussed regarding the circle, obtain an expression to find the moment of inertia of a circle about its diametrical axis. Yes or no? So there we got some values for that. Today I will be moving on further. So today I will be doing some derivation for a symmetric triangle. So I have already written the question on the board, just check it out. Obtain an expression to find the moment of inertia of a symmetric triangle about its base, and then find the moment of inertia of the triangle about centroidal axis parallel to the base. Centroidal axis parallel to the base. Let us do this derivation now. So for that, what I will be doing is I will be considering a symmetric triangle. So I will be considering a symmetric triangle. So let me call this as X, let me call this as Y. In that I will be considering a symmetric triangle. So let me call that particular thing as, this is A, this is B, this is C. So next, let me consider an elemental strip, and before that let me consider the height of this triangle has H. Let me consider the base of the triangle as B. So I think I have already told you people many times, I will always go with the part to whole concept. So now also I will be doing the same thing. Let me consider an elemental strip. And let me call that strip as EF. Okay, so I will be calling it as EF. And let me assume the thickness of that particular elemental strip as dy, and let me assume that it is at a distance y from x-axis. Then what will be the remaining distance? Total is h, this is y, obviously this needs to be h minus y. Next, the thickness of the elemental strip I have assumed it as dy. Let me assume the width of this elemental strip be b dash for time being. Okay, so mark my points. So consider a triangle ABC of area half into base into height. Also consider an elemental strip EF of width b dash and depth dy as shown in figure. That elemental strip is at a distance y from x-axis. Okay, so now what I will be doing is I will be using the concept of similar triangles. I think you people are very much familiar with the concept of similar triangles. So using similar triangle concept. Similar triangle concept. So observe here. So what I will be doing here is, so I will be considering this as the smaller triangle, CEF, and ABC as the bigger triangle. Okay, CEF as the smaller triangle and ABC as the bigger triangle. So by applying similar triangle concept, so what I can say, observe. So base of the smaller triangle divided by the base of the bigger triangle is equal to the base of, height of the smaller triangle, it is h minus y, divided by height of the bigger triangle, that is h. So let me rearrange it. So b dash will be equal to b into. So this h minus y by h, what is h by h? So it is 1. What is y by h? Let it be as it is. Let me call this as equation 1 for time being. So any doubt still here? So next what I will be doing here is, observe, first let me calculate the elemental area of this strip, that is dA, small dA. So how to calculate the elemental area? Elemental area dA is equal to. So even though this elemental strip is approximately the parallelogram, okay, it's a parallelogram, approximately I will be considering it as a rectangle because it's a very small part I have taken. That's why it is called as elemental strip. So now what I will be doing, I will be considering this as a rectangle. So for a rectangle, how to calculate the area? It is the width into depth. So what is the width? B dash. What is the depth? dy. So it is b dash into dy. Okay. So now what I will be doing? So now the moment of inertia of this elemental strip about the base AB, because just observe the question, obtain an expression to find the moment of inertia of a symmetric triangle about its base. Forget about the next question, just concentrate on about its base. So first let me calculate it about its base. So that's why what I will be doing is, so the moment of inertia of this elemental strip about the base is given by, what is the general formula to calculate the moment of inertia? It is area into distance square, correct? So now, so what is the area of this elemental strip? First, moment of inertia of this elemental strip. So DIAB, because about the base I am calculating it, is equal to area into distance square. What is that area? So it is, area is dA into, so what is the distance square? It is y square. It is y square. Okay. So now I know what is dA. So let me call this as equation 2. So what is dA? Before that, the moment of inertia for the entire diagram. So listen, the moment of inertia for the entire diagram is obtained by integrating equation 3. Will you people accept that? So now integral of DIAB is equal to integral of y square into dA. Instead of dA, what I will be writing? It is b dash into dy. Okay, one thing, let it be. Now, what is that b dash? From 1. So b dash is nothing but integral of y square, let it be as it is. So instead of b dash, we have b into, it is b into 1 minus y by h into dy. And what will happen for this? Integral of DIAB, it becomes IAB. And one more thing, in the integration, whenever you do substitution, okay, so it will become the definite integrals. So a limit needs to be applied. So we are calculating the moment of inertia about the base. Think that you are standing at the base. What is the maximum value you can reach in this direction? So here it is 0. What is the maximum value you can go? H. So it needs to be 0 to h. Okay. So now, so what are all the common factors that I can take, or the constant thing that I can take out? So b value, I can take it out. Next, let the integral be as it is. Let me take this inside. So it will become y square minus y cube by h done into dy. So now let me differentiate this. So if I integrate this, so it is y square become y cube by 3 minus, what is that y cube will become? Y to the power of 4 by 4h. Yes or no? So now, let me apply the limits. So let me do it here. So it is IAB is equal to, so B, let it be the constant term outside only. So next, y cube, so first let me apply the upper limit. So it will become h cube by 3, let it be as it is, minus. This will become h to the power of 4 divided by 4h. So finally it will become, so b into h cube by 3 minus h cube by 4. So what is the LCM of 3 and 4? It is 12. So 3 4s are, that is 4h cube minus 4 3s are, 4 3s are 3 into h, 3h cube. So finally I can say that it is bh cube by 12. So please remember this formula. Frequently I will be using it while solving the problems. So what is IAB? The moment of inertia of a symmetric triangle about its base is given by the formula IAB is equal to bh cube by 12. Okay. So I am done with the first part of the question. So obtain an expression to find the moment of inertia of a symmetric triangle about its base. I have completed it. So next, then find the moment of inertia of a triangle about centroidal axis parallel to the base. Centroidal axis parallel to the base. So observe here, AB is the base. For a symmetric triangle in the centroid, just remember the centroid part. Just remember the centroid part. In centroid, you people have studied where the centroidal axis come for a symmetric triangle. So I want the centroidal axis parallel to the base. So observe. So parallel to the base, I think you people remember that for a symmetric triangle, the centroidal axis XX lies at a distance h by 3. I think you people remember this. So the centroidal axis from the base, it lies at a distance h by 3. Yes or no? So let us keep that in your mind. So I will be rubbing this particular part because I am doing the second part of the question. So observe here, what I will be doing is using parallel axis theorem. Using parallel axis theorem. using parallel axis theorem. Observe here. What was the parallel axis theorem definition? So I will be writing it here. IAB is equal to IXX plus AH square. Yes or no? So the same concept I will be following it here. So that is using parallel axis theorem, IAB is equal to IXX plus AH square. Okay. What is IAB? Just now I have derived it. It is BH cube by 12. IXX only I need to calculate. Let us not bother about that. Plus, what is the area of the symmetric triangle? It is half into base into height. Yes or no? So it is half into, so base is B, height is H. So this is okay. I want everyone to remember the parallel axis theorem. What is that H? It is the distance between the reference axis till the centroidal axis. It is the parallel distance. It is the distance between the two parallel axes. So here the distance between the two parallel axes, because I want it with respect to the base and with respect to the centroidal axis. What is that particular distance? It is H by 3. So H square is nothing but H by 3 whole square. So let us try to solve this. So IXX, let it be as it is, plus. So it is B into H, here it is H square, it will become BH cube. And here we have 2, this is 3 square, 9, 9 2s are 18, and this is BH cube by 12. Now I want IXX, which is nothing but equal to BH cube by 12 minus BH cube by 18. So if I take the LCM, it is 36. So 12 3s are, that is 3 BH cube minus 18 2s are, 2 into BH cube, 2 BH cube. So finally, what is IXX for a symmetric triangle? It is BH cube by 36. It is BH cube by 36. Okay. So this completes the derivation of a symmetric triangle about its base and about and centroidal axis parallel to the base. Okay. Next what I will be doing is, I will be moving on with two more derivations. One is the semicircle and another one is the quadrant of a circle. So let me do it now. So now let me continue with the derivation. So the next derivation that I am going to take up is, obtain an expression to find the moment of inertia of semicircle about the centroidal axis parallel to its diameter. Okay, it's a semicircle derivation that I will be taking up now. So observe here. So now let me consider a semicircle. Let me consider a semicircle. So it needs to be little bit bigger. This is point O. Let me consider this as AB. So everywhere I have done the same thing. So what it is? So consider an elemental strip. Here also I will be doing an elemental strip, but in a different pattern, out of which this is the elemental strip. So please remember that this is the elemental strip, not the entire thing. This is the elemental strip. So while doing the derivation of the centroid, you people know that this will become r into d theta. Before that, so we will assume that this particular elemental strip is at a distance r, from the center O. And let me consider that the radius of this particular semicircle is capital R. Now let me mark the centroid of this somewhere here, and let me draw a center line for this, and let me draw one more line like this. So let me consider that this is d theta, and let me consider this angle as theta. Okay. So now keeping this in our mind, so let us proceed further. So now what I will be doing here is, so while doing the derivation of the centroid, you people know that this is r into d theta. Let me consider the vertical distance as y and the horizontal distance as x. and let me consider the thickness of this elemental strip is dr. So now note the points that I will be telling now. Okay. So note down the point that I will be telling now. Consider a semicircle of area pi r square by 2, full stop. Also consider an elemental strip. Also consider an elemental strip of thickness dr at a distance r from the center O. Okay. So now what I will be doing is, I will be calculating the area of this elemental strip. So first let me calculate the area of the elemental strip. So area of the elemental strip, area of the elemental strip dA is equal to, I think you people know that it is almost like a circular path. So it is circumference into thickness. It is the circumference into thickness. It is the circumference into thickness. So what is the circumference? It is r into d theta. What is the thickness? It is a dr. So for time being, let me call this as equation 1. So let me call this as equation 1. So now what I will be doing is, so let me take up the moment of inertia of this elemental strip about the base AB. So let me repeat the sentence. Now I will be taking the moment of inertia of this elemental strip about AB. So it is nothing but equal to, so moment of inertia of the elemental strip about AB is given by, so it is DIAB is equal to, area is dA into, what is the distance square? Distance of this from AB is y. So therefore it is y square. For time being, let me call this as equation 1. Okay. So now, so what is dA? Let me substitute that also. So DIAB finally is equal to, so what is dA? It is r into d theta into dr into y square. Let me call this as equation 2. Now the problem is the derivative d theta and dr, and we have y square and r. So y is a separate thing. So what I will be doing is, let me consider O, this is E and this point is F. Consider triangle OEF. So let me consider the triangle OEF. So what will happen? So here it is theta and this is d theta by 2. Approximately it will be equal to theta only. Okay. So now this is E point, this is F point, this is point O, this is Y, and this is hypotenuse R. Let me apply sin theta. Sin theta is equal to opposite by hypotenuse, Y by R. Or else can I say y is equal to r into sin theta? So substituting this in equation 2. So from 2, so what will happen? So DIAB is equal to r into d theta into dr into, instead of y can I say r into sin theta whole square, or if I open the brackets and all, so can I write it like this, r square, here r is there, it is r cube. Next, this will become sin square theta into, we are left out with d theta into dr. Any doubt still here? So now the moment of inertia for the entire area is obtained by integrating equation 3. So I think you people know that. So I have taken the moment of inertia of this elemental step, but I want it for the entire area. So the moment of inertia of the entire area is obtained by integrating equation 3. Yes or no? So for that reason what I will be doing is, it is integral of DIAB is equal to integral of. So for time being, let it be as it is, r cube into one more integral of sine square theta d theta. Let me close this and let me mark this as dr. So I want everyone to concentrate here. If I consider r, okay, so what is the maximum value that I can reach for entire area from center? It is 0 to r. Okay. In terms of angle, for a semicircle, what is the maximum angle that I can reach? It is 0 to 180 degree. That is 0 to pi. So now let me start integrating this. So DIAB is equal to IAB. Yes or no? Is equal to. Next, for this I will be leaving it as it is for time being. R cube, let it be like that, into. So I will be doing some alteration for this. I think from trigonometric concept, can anyone tell me what is sine square theta? So it is 1 minus cos 2 theta by 2. I think you people remember this formula. Sine square theta is equal to 1 minus cos 2 theta by 2. And d theta, let it be as it is, into dr. Okay. So now, first let me integrate that. Later on I will be coming for this. This I will not be touching it now. So half I can take it out. Now let me integrate it directly. So what is 1 into d theta? It is theta, minus what is cos 2 theta? It is sine 2 theta by 2. Yes or no? So it is sine 2 theta by 2. So what is the limit? 0 to pi, and we are still left out with dr. Any doubts in that? So now let me apply, instead of marking it here, let me mark it for this. It is 0 to pi. So now let me mark that. So half I will be taking it out. So it is 0 to r, let it be as it is. This is r cube, let it be. So now I will be marking it or applying the limits. So first I will be applying pi. So it is pi minus sine 2 pi by 2. Okay, this is the upper limit. Lower limit, I think you people know that sine 0 is 0. So 0 minus 0 is always 0. I will not be writing in detail. So it is dr. Now, can anyone tell me? So 0 to r cube, let it be as it is. Now, I want you people to tell me now, what is sine 360 degree? So sine 360 degree is 0. Okay. So now, pi minus 0 into dr, let it be as it is. So pi, can I take it out? So this will become pi by 2. Okay. So now we are left out with r cube into dr. So what is r cube integral? So it is r to the power of 4 by 4. So let me apply the limits. So this will become pi by 2 into, so this is not 0 to small r, it is 0 to capital R. Sorry, it is 0 to capital R. Everywhere it is the same, it is 0 to capital R. Okay. So now I will be going with capital R. So this will become r to the power of 4 by 4 minus, if I apply 0 for all these things, it will become 0. So can I say that it is pi r to the power of 4 by 8 about IAB? But the thing is, they have not asked us to calculate it with respect to the base. They have asked us to calculate it with respect to the axis parallel to the centroidal axis parallel to its diameter. Diameter means the base. So I think you people remember the centroid derivation. So parallel to the diameter is x-axis. So what is its value? I think you people remember that. It is 4r by 3 pi. How much is that? It is 4r by 3 pi. So what I will be doing is, for time being, let me rub this. So observe. So next, so now what I will be doing is, IAB in terms of diameter, let me write it. So IAB in terms of diameter also, let me write it down. So radius is diameter by 2 to the power of 4 by 8. So it is pi d4 by 2 to the power of 4, 16. Okay, 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 into 8, it is 128. So pi d4 by 128. So now from parallel axis theorem, because they have asked us to calculate it, so it is parallel axis theorem, because they have asked us to calculate it with respect to the centroidal axis. But what we have calculated? We have calculated with respect to the base. So for that reason, what I will be doing here is, so it is IAB is equal to IXX plus AH square. IAB just now I have calculated it. So even though I have calculated it in terms of diameter, I will be substituting it in terms of radius itself. So now it is pi r to the power of 4 by 8 is equal to IXX only I am in need of. What is the formula to calculate the area of a semicircle? It is pi r square by 2. It's pi r square by 2 into, what is that h in the parallel axis theorem? It is the distance between the two parallel lines. This is one parallel line, this is one more. So what is that particular distance? So it is 4r by 3 pi whole square. Okay. So now what is pi by 8? Okay. So pi by 8 value is, so it is pi by 8. So next, IXX is equal to pi r4 by 8 minus, so just check out what will this become. So it is pi r square, here one more r square, this will become r to the power of 4, pi r4, we have 4 square, this will become 16 divided by, so 3 square, this will become 9, so 9 into 2, 18 into pi square. So finally, can I say it like this? It is pi r4 by 8 minus, okay, so pi and pi square get cancelled, it is r4 by pi, or else can I say that this is 8r4 divided by 9 pi. So I want you people to just check out only with this particular value, pi by 8 and 8 by 9 pi. So what is the value finally? You are getting it. So it is 0.11 r to the power of 4. It is 0.11 r to the power of 4. So please remember this formula also. While solving the problem, frequently I will be using this particular formula. So IXX is equal to 0.11 r to the power of 4. 0.11 r to the power of 4. So next, there is a last derivation, that is the quadrant of a circle. That is the quadrant of a circle. If you know the semicircle derivation, 90% of the derivation is same with slight alteration. That's it. Okay. So now I will be doing the same thing. Obtain an expression to find the moment of inertia of quadrant of a circle. Instead of semicircle, I will be going with the quadrant of a circle. I will be going with the quadrant of circle. Quadrant of circle. And this one is same, about the centroidal axis parallel to its base. Parallel to its base. Okay. So now observe, let me redraw this particular diagram. So instead of the semicircle, I have taken a quadrant of a circle now, and everything is same. So let me consider an elemental strip like this. So where next let me draw a center line. This is r into d theta. This is theta. This is d theta. This distance is small r and this thickness is dr. And the total thing is the radius. The total thing is the radius. So from here I will be dropping a line and I will be calling it as y. This point O, this is E, this is F. So don't you think that all the points I have considered are the entire diagram is almost same as that of the semicircle. Okay, so now I want everyone to concentrate here now. So here also please note the points. What is that? Consider a semicircle of area pi r square by 4. Also consider an elemental strip of thickness dr, which is at a distance r from the point O as shown in figure. Next, the area of the elemental strip is given by circumference into thickness, that is r into d theta into dr. Okay. Next, the important thing is the moment of inertia of the elemental strip about the base is given by DIAB is equal to dA into y square. No doubt in that. Next, instead of this I need to do some more here. I will be doing it here only so that I can alter this. So now what I will be doing is DIAB. So I think I need to rub it. There is no other go. Let me check it out. So next what I will be doing here is, let me substitute all the values here. It is DIAB is equal to, what is dA? Just now we have calculated, it is r into d theta into dr. It is r into d theta into dr into y square into y square. So for time being, let me call this as equation 2. But y, let me take it from the triangle. Consider triangle OEF. So it's a triangle now. This is y, this is r, this is theta. Observe here. This angle from the center it is theta plus d theta by 2. So d theta by 2, it's very small. So that's why I have taken it as theta only. So I am applying sine theta. Sine theta is y by r, or y is equal to r into sine theta. So now let me substitute it into from 2. So DIAB. So from 2 DIAB is equal to, so everything is same, r into d theta into dr into, instead of y square it is r square into sine square theta. So let me rearrange it a little bit. So this will become r cube into sine square theta into d theta into dr. This let it be IAB itself. Let me call this as equation 3. Yes or no? So I am following the same step as that of the semicircle derivation. Okay. Now the moment of inertia for the entire diagram is obtained by integrating equation 3. So what I need to do now? So let me integrate this. It is DIAB is equal to, so this r cube, let it be for timing as it is, into sine square theta d theta, okay, into dr. Now, as we have done the substitution, I need to put the limits. For R, 0 to R is the limit, 0 to capital R. For the angle, what is the maximum angle in the quadrant of a circle? 0 to pi by 2. 0 to pi by 2. So, just go with the things now. So, DIAB is nothing but IAB is equal to integral of 0 to R cube. I will not be touching it for time being. Everything is same. So, now it is sine square theta. I can do it like this. Yeah. So, it is 0 to pi by 2. Let it be as it is. Sine square theta 1 minus cos 2 theta by 2 into d theta into dr. So, into d theta into dr. So, I will be taking half outside. So, I will be taking r outside, r cube, let it be as it is. So, now what is 1 into d theta? So, it is theta minus cos 2 theta, it is sin 2 theta by 2. So, it is 0 to pi by 2 now into dr. So, next what will happen? So, I think it is there only. Anyhow. So, next it is half into 0 to r cube, let it be. Now, let me apply the upper limit. So, directly I will be writing it. Will you people able to guess that? Okay, or else. So, it is pi by 2, right? So, it is pi by 2 minus, first I am applying the upper limit. So, 2 into pi by 2, 2 get cancelled, it will be sin pi by 2 minus lower limit if I apply, it is 0 into dr into dr. Into dr. So, now what will happen? IAB is equal to half into integral of 0 to r. So, pi by 2 let it be. What is sin pi? Sin 180 degree is also 0. So, pi by 2 we will be left out with. So, only we will be left out with pi by 2, okay, because this will become 0 into dr. So, if I take it out, it will become pi by 4. Next, integral of 0 to r. I will do one thing. Let me integrate this. What is r cube? It is r to the power of 4 by 4 and the limit is 0 to r. So, now it is pi by 4 into r to the power of 4 by 4 is the upper limit. If I apply the lower limit, it will be like this. It is pi r 4 by 16. So, it is IAB, but I want the IXX parallel to the base. So, using parallel axis theorem, using parallel axis theorem, using parallel axis theorem. I think you people remember. So, it is IAB is equal to IXX plus AH square. IAB just now we have calculated it, pi r 4 by 16 is equal to IXX plus area of a semicircle, it is pi r square by 4 into h. H is nothing but, so now here also I will be marking using the concept of centroid. So, parallel to the base, a centroidal axis needs to be drawn, that is XX. What is that particular distance? So, what is this distance? From the centroid concept, it is 4r by 3 pi. I think you people remember that. So, it is 4r by 3 pi. So, it is 4r by 3 pi whole square. Okay. Now, IXX is equal to pi r 4 by 16 minus, if I transfer everything towards that side, let me check it out. It is pi into r to the power of 4. So, this will become 16 divided by, this will become 12, not 12, 3 square is 9 fours are 36, it becomes into pi square. So finally, by altering a little bit, 16 and this one. So it is pi r4, 4 fours are 4 nines are, and this pi will get cancelled. So it will become this one, 4r to the power of 4 by pi. After solving it, you people will be left out with in terms of radius. What is that? It is 0.055. It's 0.055 r to the power of 4. So I want everyone to remember this. So this particular formula also frequently I will be using it. Okay. So this completes all the derivations of moment of inertia. So let me tell you people what are all the derivations that I have done. So the first one, it was to find the moment of inertia of a plane area. Ixx is equal to integral of y square dA. Iyy, it is nothing but integral of x square dA. Next, polar moment of inertia. Izz is equal to integral of r square into dA. Next, I moved on with the radius of gyration. So that is kxx is equal to square root of ixx by a. Next, kyy is equal to square root of iyy by a. Then I moved on with the perpendicular axis theorem. Izz is equal to ixx plus iyy. Then I moved on with the parallel axis theorem. That is IAB is equal to IXX plus AH square. Then I moved on with the next derivation, which is that is obtain an expression to find the moment of inertia of a rectangle from first principle or by method of integration. Okay, next I moved on with the circle derivation. Next I moved on with the symmetric triangle derivation. Next it was the semicircle, and next it was the quadrant of a circle, that is this one. Okay, so this completes the derivation part.